This is factory I/O. As I told you guys, I've been looking for a nice way to write some ladder logic, intended basically to find out which proximity sensors has a failure, or it's damaged or something. Therefore, it is not being activated or deactivated. Which right over here, if you take a look at the factory I/O, and you see this icon right here, if you click on it, you're going to see that we're injecting an on failure. And if you click on and again, so we are able to inject an off failure. So this is a setup that I did with 4 of these pick and place cylinders. Let me set it up. Change the view over here. All right, I'm going to start up the pick and place with no failures at all, just to make the application run completely. And as you see, I clicked one of these sensors here. So let me get rid of it. The reason I did this setup is just basically to show the ladder logic responsible for detecting which sensor has a failure or a problem. So I'm going to reset everything by pressing the stop button, and I'm going to start it up again. But this time I am going to click maybe pick and place number 1. I'm going to click a failure on the movement, and I'm going to create an on failure. As you can see here, I'm running my code, and I got my sequencing running. It's running in automatic. So let me go ahead and push the start button. Oh well, I forgot to reset the logic. All right, let's do it again. All right, the pick and place number 1 stopped movement. If you can see this, moving X axis. If I go to my sequencer, I find out that I was running number 1. This is the pick and place number 1. And going to the pick and place number 1, I see that my stage programming here stopped on run number 7. How did I get into that? How did I discover that I stopped in run number 7? So this is basically what the programming did. I have a stage number 100 that's starting at the same time that the subroutine stage 0 starts up again. As you can see, I'm using this jump to multiple stages, and I'm doing stage 1 and stage 100. So let's go back to a stage 100, and you see that I have a timer in here, and that timer, it's running for 15 seconds, which is right here. So it's already time out, and when it does that, I get this bit turn on, and what I do, I just call a subroutine that I created. This is a subroutine that is called find bad proximity. And what it's doing here is basically running a for loop, and this for loop, it's making sure that it's running this reference function. And if you can see, let me go to the help file and check that reference function. Let me just go ahead and type reference. And here we go. The reference function is right over here. What it does is you basically look at the memory address and find out what that number is. The memory block that I'm looking at over here, it says memory block 9. So let me see what's memory block 9 right over here. As you can see, those are my C bits, my control bits. And so this is what I'm doing. I'm just increasing my for loops, and I'm telling that my reference to give me the address value or the memory value or the memory number found on my variable, my stepping or increasing iterating variable, which is in this case is v1. So you may ask, how do I turn my stage programming, meaning that my stage number here, which is the one having problem. Which one is it? Is it number 7? Yeah, right here, number 7. Okay, this number 7, it's lit up. It means that the sequence was running just fine, and it got stuck on this S7 stage. The reason I'm finding exactly that stage number is because using the map function or map IO, I happen to map all my stages from my pick and place into C bits. So that's why my for loop was able to iterate through all my C bits, and when it found one that has a number 1 on it, or it was turned on, I related that to my stage, pick and place stage number 4, or number 7 in this case, which is a C27. So if we go back to my for loops, you're going to find out that my for loop is indeed giving me number 27. And right over here on my data view, I see my bat sensor number. It is indeed 27. So what do I do with that number? Well, in order for me to inform the operator that we have a warning condition, is by creating an event manager database. And this is the software, Seymour software, that I'm using for my HMIs. And right over here, you see message number 27. That's what I put into that word. The number is a D reference memory type, and I have a number 27 in there, which is synchronizing or relating to this message that I created, in which inside it I have number 27 on it. So let's go ahead and do a simulation of this HMI and find out what happened when the number 27 it's entered into this word. So I'm going to go ahead and put 27 into this bat proximity tag, press enter, and this is what I got. I got a, hold on, let me make it bigger. There you go. So it says, it pops up a message saying that pick and place number 1 is missing a signal, and to check the proximity sensor or the valve for that cylinder. And it's also giving me the tag name, which is pick and place 1, move detect. If we go back to my stage programming and look at stage number 7, I seem to have the number, the name of the Modbus address incorrectly, right over here. So I'm going to go ahead and change that real quick. which is the event manager tag 27. When I double click on it, it says moving in my X condition. Whoops. Which means two things. I entered the number incorrectly, or the event manager is creating. Oh, my bad. It was my bad. So this is the message that the operator is going to get, which is PP-1 moving X, and that correlates perfectly with my stage programming, telling me that on these specific subroutines I got stuck on this stage, and this is the culprit. This sensor did not came up. And if we go back to factory IO, we see that that is precisely what it is. It got an on failure, which means it remained on while I am expecting it to turn off right over here. You see? So just to recap, what you have to do is create a stage that is always on. So while the main subroutine is running, this stage is always on and is basically monitoring a timer which is going to time out. And when it does time out, it's gonna shoot a subroutine which is going to start up a for loop, and that for loop has some custom variables. If you see the variables that I need when I call that subroutines, let me go back to pick and place 1. As you can see, the parameters that I'm passing to my subroutines, it is basically the number from 20, which is my stage number, and I'm passing for loop from, and D5, which is my for loop 2. So those parameters get injected into my for loop as variable number 20 and 99. Let me see if it's correct. You see 20 and 99. So with just one subroutine and having a timer on each of your stage programming, managing your pick and place movement and motion, so I'm able to tell just immediately, almost instantly, which sensor and which proximity has a failure on it. So therefore I am able to reset my project. You see, it got stuck again. So let me just get rid of that. Let me reset the routine and run it again. All right, guys. Let me know if you have any questions. This is the my way to check if the machine has a failure on any sensors, any laser sensor, any proximity sensor, any retroreflective sensors, and I am able to check basically all type of inputs. This runs beautifully, whether it's a small machine with 10 input and outputs, or if it's a huge machine with hundreds of sensors. A loop is going to be running at high speed and detecting which one has a failure on it. Okay, guys. Let me know if you have any question. I'll see you on the next video. Thanks.